I think we are live now. So, good morning, good evening, and good afternoon. Hi, everyone. Welcome to the day two of Testmu Conference. I hope everybody is having a great day and it is really exciting session ahead. Before we start the session, we would like to thank all our partners for supporting and promoting us for this event. So, let me introduce to our session speaker, Benjamin Bischoff. Isn't it interesting when a game and application developer for 15 years decides to dedicate his career towards automation testing? Currently, he works at Trivago to test their web applications. In his talk, he is going to talk about understanding how automation engineers can simplify run tests using Make to see the benefits of Makefiles for different use cases and realize that old technologies can also be used to solve new problems. Over to you now, Benjamin.
Hello, everyone. Like you said, good morning, good afternoon, good night, wherever you are. I will share my screen. I think that's a good idea. And now you should be able to see the slides. Very nice. So, hello again. This is Simplifying Your Test Runs with Make. I'm very excited to be here for LambdaTest Testmu Conference 2022 to share this with you. And let's jump right into this. So thanks again for the introduction. This is me. I'm a test automation engineer. I have about 7 years of software development engineering experience in testing. I've been in IT for about 22 years, the first 15 years as a 100% developer. And then gradually I decided to move into the QA direction with the experience of a software tester to help there. And I haven't looked back ever since. At Trivago, I've been working for around 6 years in different roles, first testing the web application, and now more in the backend and API testing. But what I want to talk about today is applicable to all kinds of testing, basically. Two credits to get out of the way. In 2019, my colleague Simon Bruggen, who is also still at Trivago, wrote a blog article, Makefiles in 2019, Why They Still Matter. And he also did a talk on this, and this heavily inspired me to do this one. And the other one, Felix von Leitner did a talk, The Useful Harmless Spectrum, that is also reflected here, which is more about the psychological aspect of using new tools versus old tools. So let's start. And I decided to start with How I Met Your Mother. This is also by now considered an older series, I guess, but I hope many of you remember it. And especially there was one episode called Architect of Destruction. But don't worry, even if you don't know this show, you will understand what I mean. So Barney Stinson, one of the characters in the show, said to Ted Mosby, I'm going to give you 4 words to live by. New is always better. And Ted said, and this theory applies to everything. And Barney said, everything. And that made me think, is new always better? Let's face it, developers love new things. They love to try new software, new technologies. We, not only developers, also QA engineers, testers, everyone loves to try new things. And learning new things is crucial, of course, to progress in our jobs and in our lives. You need to learn new things. But there is something that I call the new is always better dilemma. And it's 4 parts. Familiarity. because getting comfortable with new solutions takes a lot of time, especially technologies. Then you have the maturity aspect, because new software can have flaws and it can have unwanted dependencies. Uh, you might have seen software that pulls in other dependencies that in turn pull in more dependencies. So you end up in this dependency hell and you don't know what is happening under the hood. Also, there is this aspect that I have seen before in a job at a company I won't mention. Management received a proof of concept from the development team, and they considered it a final product and wanted to release it, even though it was just a try. So this is a thing that can happen if you jump on new things too quickly. And also what a colleague of mine calls the tractor factor, that is commonly referred as the bus factor. A single developer can be the only one who knows most about the software or a technology or a methodology. So that means if this developer is hit by a tractor, nobody understands the solution anymore. And of course, if you learn a new tool, you absolutely want to use it. But that is another thing that is dangerous. And probably most of you know this quote by Abraham Maslow from 1966. I suppose it is tempting if the only tool you have is a hammer to treat everything as if it were a nail. So if you spend a lot of time learning a new thing, you want to use it for many, many, many problems, even if it's not the right tool to use. So, what is Make? Sorry for the long introduction, but I think it's an important thing to keep in mind and to talk about. So according to our favorite source of knowledge, Wikipedia, Make is applicable to any process that involves executing arbitrary commands to transform a source file to a target result. So typically this has been used as a format to compile software, like in C, because you can express all the steps that should happen in a Makefile. But this says any process. So it doesn't have to be this compiling process. It can be a testing process. It can be basically anything you want to do. So a few facts about Make. It was invented by Stuart Feldman in 1976 at Bell Labs. And I still think it's amazing to read this because this is actually 2 years older than I am. And like I said, initially it was a build automation tool for executable programs. It used to and still is built natively into Unix, Linux, and macOS operating systems. So if you use a Mac or Linux or Unix, if you type make on the command line, you will see it's included. For Windows, it's not necessarily included, but there are tools like 𝒄𝒏𝒄𝒆, Make for Windows, which is a Windows port of Make, or the Windows subsystem for Linux, the newer way to run Linux in Windows. So that means you also have it there. Some cons about Make: it can be hard to master. The syntax is pretty straightforward, but learning the quirks of it can be hard because, and that is something that I personally don't like about any language, dependent on tabs and spaces. And this is something you have to get used to or use an IDE that can handle this for you properly. Bugs can be tricky to figure out. because oftentimes you don't get a straightforward error message from make, but more like a strange return code. But I'll show you that later. But there are way more pros. It's basically available everywhere, like on every client computer, on every server, many Docker containers. If they're built on Linux, they have it because it's part of the OS. It's a proven solution. Like I said, it's from 1976 and it's working. It's consistent across local and CI/CD builds. So if a Makefile runs properly on your local system, it will run properly on a CI/CD system like Jenkins or GitHub Actions. It's very easy to learn, as you will see, and also very flexible. And this is a thing that is often overlooked. It's never out of sync with documentation, because since the Makefile syntax is so straightforward, it can act as a means of additional documentation, because it's very easy to follow the steps that are needed to test or build a software. So let's look at the different parts of a Makefile. That is, first, of course, how do you run it? So you always start with make, and make is the name of the tool to run your Makefiles. And it automatically looks for a file called Makefile, or Makefile with a capital M, to run. But as you see above with the -f switch, you can actually call your Makefile whatever you want. But I would strongly recommend calling it just Makefile to stick to the convention. And it returns a status code of 0 if it's successful, which makes it really nice for CI/CD pipelines and embedded into other like batch operations, because you instantly know if it was successful or not. So make has rules. And this is where it gets a little tricky, but I have some examples for it. A make rule typically creates a target file, and it will check this target file. And this check of a target file is mostly dependent on timestamps. As you will see a little later, it does not have to create a target file. There's a little workaround that we can use to reach that, and this is actually what makes it possible to use it for testing. Another part of Makefiles are recipes, and a recipe is an action that make invokes. And an action can be made up of multiple commands. It can also be just one command. And this is where you have to be careful, because each line, each command has to be started with a tab. If you use a text editor that converts tabs to spaces, you will have a hard time. So make sure when you write a Makefile that you use an editor that handles tabs properly. So this is a very simple Makefile. And you have the dependency.text in the first line. This is the name of the rule. So the rule is called dependency.text. And by convention, make expects this rule to create a file of the same name. So it expects the dependency.txt file to be there after this recipe runs. And to satisfy this, we just write hello world to a file called dependency.text, and then echo file is created. And the @ symbol in front of the echo, in case you wonder, just suppresses the printing of the statement itself. Otherwise, make would print echo, hello world, and so on. But with the @file symbol, it won't do it. So this is how it looks. Let's see if we can run it. No, we can't. It's very interesting because we tried it before to run it. This is very unfortunate, I have to say. So let me try it quickly with the next one. It also doesn't run anymore. That is not very nice. But then I will show you this another way. So let me quickly stop sharing and I will share my terminal. Please let me know if you see this.
Yep, visible.
Perfect. Because I was expecting that something like this might happen. Let me show you that I have a Makefile here that does the same thing that I had in the slides. And if I do make, it will write hello world to the dependency.txt file. I can also show you that it now exists. And I can show you that the dependency.txt file now has hello world in it. And if I now run the make command again, it will tell me dependency.txt is already up to date. Because like I said, make will check for exactly this, if the dependency.txt is there. So that means if I remove it and run make again, it will recreate it. That's the basic operation of make. So let me go back to the presentation, and I will have to jump back and forth of this presentation. I'm very sorry for this confusion. Okay. There we go again. So again, I'm sorry for this technical difficulty. We will have to jump back and forth, but fortunately I have everything prepared. So we can have prerequisites in Makefiles. That means you have, in this case, a final.txt rule that is green. That is like the dependency.txt rule that we had before. And you will see that this will create a final.txt. But it will also try to read a dependency.txt file and write this content to the final txt. And now the yellow part comes in, the dependency.txt, that is following the final.txt file with a colon. That means that final.txt is dependent on dependency.txt. So it will first run the dependency and then run the final.txt rule. And again, I can switch to my terminal. There we go. I will go to my second Makefile. Again, you will see that this is exactly what I'm showing in the slides. And if I run make, you see that it will first create the dependency text file and then read this dependency text file and add this content to the final text. So here you will see both. Again, if I run make again, it will say final.txt is up to date. But if I now remove the dependency.txt file, so we have only the final.txt and the make file, it will recreate both because the dependency was not satisfied. So it couldn't find the dependency.txt, so it executed both again. That means whenever a dependency changes, it rebuilds everything else. All right, great. So what happens if we want to build or execute a rule that does not create a file? And typically when we run software tests, this is what happens. We don't necessarily have a lot of files that we want to create. Like here, let's add a clean dependency. So it's exactly the same as before. Final text depends on dependency text, but dependency text depends on clean. And the clean recipe is removing both files. So with this Makefile, we force everything to be removed first and then rebuilt. And to make sure that make knows that this rule, clean, does not create a file, we can tell it with the .phony that this won't create a file. So it's a phony rule that for make doesn't really do anything. And why do we do that? We do that because if for any reason then somebody writes a file called clean to the directory of the Makefile, this rule would not execute because make would think, okay, the clean file is already there. And we absolutely don't want that. I don't think this will ever happen, but this is what it's there for. All right. Back to this one. There we have the phony. So here, if I say make, see in the first lines, it removes dependency.txt and final text, and then does exactly the same thing again. So after that operation, we have the dependency text and final text again. But here, because we clean everything with the clean recipe, if we run it again, it will do the exact same thing again. And that is what we can use for test runs. This is actually fun, switching back and forth. All right. So a question you might have, and that I certainly had, is when does make build what? And how can you influence the order of the rules? Well, if you have a Makefile like this, it's not really that apparent what it will do in which order. In this case, we have the clean on top, and this one just says clean up old files. But in this case, even if we have many rules in there and many recipes, only the yellow one, only the clean will be executed when you run make, because the clean rule is the first in the file. So make will generally execute the first one it encounters and then checks for any dependencies. And because clean does not have any dependencies, it will ignore everything else. I can also demonstrate this again. Hope you're not getting tired of seeing me all the time in between. Thank you for the hearts. All right, here we have the build order. Exactly this file here. The clean rule is the first without dependencies. So when I call make, it will just do clean up old files, nothing else. And I can show you two ways to influence how you can to see how you can influence the build order. One is to just reverse everything. So if you see the second example that I can show you without going back to the slides. Here we have the exact same rules, but upside down. That means we have the deploy here, and deploy is dependent on build. Build is dependent on clean, and then we have clean. If I run this now, since it will now start with the deploy rule, it executes everything. And you see that it does clean up old files first, because this is the last rule that doesn't have any dependency. And then it will do the build, because this is the one dependent on this. And then it will do the deploy, because this is the very first one that is dependent on build. So back here, that is what I just showed you. You have the test, deploy, build, and the clean. So it analyzes the file first and the rules and the dependencies, and then works its way back up. By the way, you can, of course, also specify the rule directly when calling the make file. I will show you that in the next time we jump back and forth, because you can also call any rule that is written in the make file directly. But if you run only make without specifying the rule, then it will execute the first one. Or in case if you have dependencies, it will analyze the file first and then construct the tree of rules it should execute in that particular order. So parameters, because that is actually what is very crucial for testing. Here we can say with the first line, browser question mark equals Firefox. This is just an example that could potentially run a UI test. That means we set the browser variable to Firefox. And the question mark equals means we set it in case it is not specified from the outside. So if we run this thing, it should print testing with browser Firefox. And you see in the echo line, the $ curly brace browser curly brace. That is how we can inject this parameter into a string or use it in any other way. Like we use it to inject certain parameters into Maven commands to run tests. And you see down there, you can also, with the phony, specify many rules that you want to be considered as phony. Yeah, in this case, we don't have a deploy rule anywhere defined, but Make doesn't really care about that. It will just accept it, and if you later add a deploy rule, it will consider this phony as well. And because this is not running, I will go back to my trusty, always functioning terminal. And go to my example 5. There's only the Makefile in it. There is the parameter Firefox. So when I do just make, it says testing with browser Firefox. But when I do make, and then you see that my terminal even gives me a code completion. Let's say browser Chrome. It will say testing with browser Chrome. And to show you that, that you can also invoke a rule directly, you can also do make test, and it will do the same thing. So if you have many rules and you have many different use cases in one Makefile, you can also run those individually. And in this case, you can also pass in the browser, IE11, rest in peace. But there we go. It's the IE11. A little tip is this weird line. And I will also demonstrate this. And don't worry, I also have a Git repository with all the example code that I will share afterwards. This is a command that reads the Makefile itself, the yellow AWK command. It reads through the Makefile and prints out the commands and the rule names. Sorry, not the commands, but the comments and the rule names. So I will show you. Excuse me for jumping back and forth so quickly this time. There we go. Let me go to the help example. There it is, the weird line. But now, when I run make, it will print out this help that looks like any other command line tool that you might be used to. So it tells me, okay, you have the rule help, and I can try it. Make help will show the same thing, show this help, and with make test, this would start a test. So there are ways to make this more user-friendly, and I would highly recommend using something like this, even though it might be, it might look a little strange. But the goal when writing software like this or when writing tools like this is to make it very, very user-friendly and straightforward. Like I said, the example code is available in my GitHub repository under Bischoff dev/make_examples, or you can scan the QR code in the top right corner. This will also bring you right to it. But like I said, I will also share it with you afterwards. So this was all I wanted to show you, because this is the basic stuff of Makefiles. And with this basic stuff, you can basically do anything you want, because Make is just a wrapper, and a wrapper that can execute any arbitrary command. So I think this is not too complex. And Stuart Feldman, the creator of Make, actually said Makefiles were text files, not magically encoded binaries, because that was the Unix ethos. Printable, debuggable, understandable stuff. And I think this indeed is. You can just use a command line text editor to edit them. You can read them, you can understand them, and you can debug them. And I think in this case, the limitation of Makefiles is actually an advantage. If you look at other big build systems like Maven or Gradle or whatever you might use, there's a lot those tools can do, especially Gradle can basically do anything you want. But if you have a big Gradle script or any solution like this, it might get very, very complex and not very straightforward to use. And then you need a documentation about how to run it, how to build it. With a Makefile, you just dump a Makefile into any one of your projects and use this to build your software, to deploy your software, to test your software with make build, make test, make deploy. And this is actually a real world example from our tests, our UI tests. That is almost the complete Maven command with all the options possible that we can use to test our website. And if you show someone this thing, they might think you're crazy and you need a huge documentation for it. And for us, it made a big, big difference to be able to turn this into this. So you do a make test local. If you want to test on your local system, you provide a base URL and you provide one or more browsers you want to open. And everything else is handled by the Makefile or by a shell script that is invoked with the Makefile. But make is for us always the first point of contact. Here, if you want to test on a grid, on a test grid, you just provide test-grid. For us, it's not test-grid, it's actually the name of a commercial device cloud provider. And even if you have many more, you can just make a new make rule for any one of them. And you don't have to change anything else for the user. Also, it enabled us to test on browsers and devices at the same time, also specify the exact test features and tags and all the other application-specific stuff we wanted to pass. And because of the help function that I showed you, it's also very apparent for a user what each parameter can do. And this is an example from a GitHub action. And you see that the make command is pretty much the same. In this case, the parameter values just come from other GitHub actions or GitHub secrets. So that makes it also very nice to integrate into CI/CD systems in the same way you run them locally. Just a side note, pun intended, because there is a thing called just. And just is heavily inspired by make. It's a newer solution. This is the command running part of make. So it does not have this I expect a file to be there in the end thing. It runs on Linux, macOS, and Windows, but it has to be installed. So I think it has to be installed makes it worse than make, because make is just there. But what's nice is you don't need a phony or anything of this make workarounds to use it. And it also supports some more commands. I do like it, but I still lean towards make because it's just a little simpler. But you see how similar it is if you just look at this just file. So make runs make files, just runs just files. It looks basically the same as make, just without the phony. That just as a side note. So coming back to what we talked about before, every project is different. That is important. And we should use the right tool for the job. You might look at make and say, this is not the right tool for our job. Then please don't use it. Don't use it because I said it's a good thing for us. You have to look at your use case and your environment to check if this is something you should consider. Decouple progress from technology. Super important. Progress does not necessarily mean you use the newest software or you update to a newer version of something. Progress can mean using a very, very old tool to make it easier for the users. Testing is a team effort. So we should definitely listen to all of our customers all the time and hide the complexity. Like I showed you the Maven command, just insane to remember, but if you use the Makefile, it's much, much easier. And to be frank, it also makes it easier for us as automation engineers or QA engineers to use our own solutions. So coming back to the Architect of Destruction, How I Met Your Mother episode, that was the original episode, but I would rewrite it a little bit like this. I'm going to give you 5 words to live by. New is not always better. And Ted Mosby says, I agree. So with this, thank you very much, TestMu Conference, for having me. I hope it was all right, even though we had
Hello, Benjamin, are you audible?
Yes, I'm here. I don't know when you lost me. I just realized I dropped out. So in case
No
you missed
issues.
it, I just said thank you for having me and sticking around and bearing with the switching of the screens.
Yes.
I hope you learned something, or you
Yep.
want to try make, or say no, this is not for me.
It was really easy to follow along. So yeah, definitely you're gonna try and make. And thank you for such an insightful session. And we would like to answer some Q&A. Uh, just let me take it on this stage. This is a question asked by Ruth. Thanks for a sure, a well-explained session. We use Makefiles in our Jenkins pipelines, and until now, I have never really understood what they really were doing. Do you see this being a good use of Makefiles?
I definitely do if they are well written and if they do helpful things. Just using makefiles for the sake of using makefiles, it's not really necessary. But if they, like I said, hide certain complexity, it makes total sense. So you should definitely just look into the makefiles and try to follow along, because usually it's really easy to just follow along the dependency tree in the Makefile and see exactly what they're doing. It can just be overwhelming if it's a larger one and you don't know how Make handles all the rules and the dependent rules. But now hopefully you do. And I would certainly recommend using Make for CI/CD.
Uh, Moving to the next question. Uh, but this is how we always tested Make based project. How do you think simplifying things do you not using Make?
How does this simplify things that do not use Make? I'm not sure I get this question. But if you mean how Make, if you put it on top of something, can be beneficial, it's like I said, it hides the complexity. It can do its magic under the hood without exposing this to the users, and just make it easier to run certain things. I don't
Okay,
know if
got it.
this is
Yeah,
what
this
you
is.
meant.
Is there any wrappers that can be utilized in the Make?
Make can use and call basically everything that you can call with a shell script. Make can even be used to call other larger shell script. In fact, we do exactly that. So we use simple make rules, and each rule just calls a corresponding shell script. And in this shell script, we can do a lot of things like constructing the huge Maven calls we are using, or it can use other solutions under the hood to make REST calls or whatever you want. The thing with Make is it can just wrap around everything and make it easier.
I'd like to take up the last question as well. In your experience, how often do we train the team with this type of commands? And such a great tool such as Make or Just to complement the team automation knowledge.
The thing is, for us, every single repository includes Makefiles now. So once you start using them, you just use them everywhere. And once you use them everywhere, you don't really have to train your team that much because everyone is used to Makefiles being there. And everything I do first when seeing a new repository is checking out the Makefile and looking if there is a make help in it or a make test. And I run make test, and then it tests the project with whatever framework, with whatever technology there is. And if you're really lucky, there's also a make deploy that helps you just deploying it locally, and then you're done. So you don't have to be trained in certain frameworks or certain technologies. You don't need to know necessarily about Docker and things, but you just have to know, okay, there's a make deploy. And the rest is just handled by whoever is responsible for deploying.
Thank you for answering the questions. We will be hosting all our recorded sessions on YouTube, so you can go check it back and listen to them again and share with your viewers. Till then, happy testing and have a great day ahead.
Goodbye.